Well, welcome back. Problem 23 is about histograms and how you, and really about what type of data do they comprise and how to take the data off of it. It says histogram below displays the waiting times in minutes for patients in a dentist office, and you've got that plot. And it says which of the following could be the median for the waiting time. So remember, the waiting times have, the histograms have along the bottom the bin structure that you've created when you've put together the frequency table for which this histogram is the graphic. So it's the bin numbers and their lower and upper bounds along the horizontal, and it's the counts generally. The counts, sometimes the relative frequencies, but here this is just the counts. So if you want to find the median, you really need to kind of find the total counts, cut it in half, and look to see where it falls. So let's do that. And all I have to do is go bar by bar and see what that represents. First bar represents 80. Yeah. So the next bar looks like 50. The next bar looks like 25, and so on. And so there's the numerical data associated with the graphic. And if I just add that up, 80 plus 50 is 130, plus 25 is 155, plus 10 is 165, plus another 10 is 175. So it looks like the total count is about 175. And if I divide that by 2, it's 82.5. So the median is somewhere around 82, 83, 82 on one side, 82 on the other. And where would that fall? Well, it doesn't fall in the first bin because that only has 80. But the second bin goes from 80 up to 130. So the median would fall somewhere then somewhere in that second bin, which runs between 5 and 10, and therefore if we look at our choices down below, the only one that falls within 5 to 10 is B, 7.25. Okay, simple as that. All right, well, problem 24 here is, for me at least, a two-calculator problem. Let me show you what I mean by that. If I just read the problem to you. It says, based on a survey of a random sample of 900 adults in the United States, a journalist reports that 60% of the adults are in favor of increasing the minimum hourly wage. If the reported percent has a margin of error of 2.7 percentage points, which of the following is closest to the level of confidence? So this is sort of an inside-out problem. It involves confidence intervals for proportions. And what it's asking you to do is take the fact that the margin of error is known, 0.027, and calculate the level of confidence. So how the heck do we do that? You just have to remember that the margin of error for proportions is z alpha over 2 times the square root of p hat q hat all over n. And p hat is the sample proportion. Q hat is 1 minus p hat. N is the sample size. And that leaves E is the margin of error. And what we're after is z alpha over 2, which is the critical value. So where do all these things come from? What we're going to do is we're going to calculate z alpha over 2 by just turning this inside out. I'm going to put the square root over on the other side, and I'm going to write this equation as E square root p hat q hat all over n is equal to z alpha over 2. We're going to calculate z alpha over 2. Here's what we're going to do. We're going to calculate z alpha over 2. From that, we're going to find
alpha, and from that we're going to find 1 minus alpha, the level of confidence. That is the level of confidence which we're being asked for. So let's get to it. I'm not liking this pen. It might be running low. Switch colors here. Let me just insert things. Margin of error 0.0027, 2.7 percentage points. All over the square root of, we were given the sample percentage as 60%. We have to multiply that by 1 minus 60%. And we have to divide by the sample size, which was given as 900. Okay, so here comes the first calculator. Promise 2. Let me go 0.6, enter 0.4 times 900, divide, take the square root of that, turn it upside down, 0.027 times, and I get a number that might look familiar to you, 1.653. That's a critical value, yep. In a confidence interval, right, if I was to draw a normal curve, then this would be 1.653 and this would be minus 1.653. So what I have to do is find either one of these areas, because either one of these areas is alpha over 2, right? That's what the notation Z alpha over 2 means. It's the critical value that's got alpha over 2 to its extreme size. So in order to do that, in order to find areas, you make use of the CDF functions, and of course this is, since it's Z, that's telegraphing to you that this is a normal distribution. So let me go to normal CDF. Let me just do this. Let me go to normal CDF. And let me just see, hold on. Yeah, I already have minus 1e to the 99th here, so let me put minus 1.653 right there, 0 and 1. I could have put 1.653 here and plus 1e to the 99th and found that area, but I'm finding this area instead. Again, that's alpha over 2, and that is, once I push the button on the second calculator here, yeah, 0.049, and that means that alpha is, I'm going to say it's about equal to 0.05 times 2, it's about equal to 0.1, and that means that the level of confidence, 1 minus alpha, is about equal to 0.90, and that's the answer that we're after. Okay? Good problem. That was 24, let's move on to 25.